Hi students, this is Dr. Kavita from SNS College of Technology. In this session we will see about the elastic theory of the torsion. So in a previous session we have seen that what is the meaning of torsion and where it is used, what are the types of shafts we are using, so what are the assumptions and some key formulas we saw that in the previous session. So in this session we will see about the why this torsional equation is important. So what is the importance of the torsional equation and where exactly this torsional equation is used, in which places, and the assumptions we were used, and also the terminologies used, different terminologies we are using to derive this equation, and we will see about the derivation and some of the important key steps for deriving this torsional equation for the circular shaft. So now if you are taking this, so this is the main important thing to the application of the torsional equation. So here whenever if you are seeing this, so this is the steel structure. In these places you can see the so many connections they were used. So different types of connections are there. It may be a riveted, bolted, and also the welding. So in most of the places we are using the bolted connections. So in that places this the determination of stresses is very important. Okay, in the structural element the knowing of the stresses, shear stress is very important, and also the places where subjected to the torsion, there will be the rotation of the structure may be there, and we have to know the computation of this rotation. And here you can see this. So this is the plate girder they were used. Here this is a failure which is happened in the plate girder. So here so while the construction itself, this I section, that is a beam girder which got failed. So due to the improper determination of the torsion, and also the selection of the material and the selection of the sizes also the important. Okay, so whenever we are any element or any material is subjected to the torsion, the shape and the size and the grades of these sections are very important. And if you are seeing that the torsional equation, so here you can see this. So this is the I sections, and here they were using the bracings. So why we are using these bracings? To avoid the lateral forces, the failure of lateral forces, failure due to the lateral forces, we are providing the bracings. Okay, so here if you are not providing this lateral and also the intermediate bracing, there will be the chances of the twisting of the this I section may be happened due to the wind pressure or maybe any type of loading. And if you are taking this, so this is a multi-story building. Here also they were using the bracings. Okay, so here if you are not providing, if you are not calculating the torsional effects due to the wind pressure or it may be the earthquake pressure, we can't get the proper design. Okay, if you are doing the proper design, we were providing the bracings to avoid this torsion effects. Okay, so therefore the calculation of torsion is very important in designing of such buildings. So here you can see this different models they have taken, how the torsion is occurred and how the buildings are subjected to the torsion. Okay. So now in the previous session also just we have see that this assumption. So now we will recollect it. The material what we are taking should be the homogeneous. So which means it should be the elastic throughout this the taken section, and it should obey the Hooke's law. That is stress should be directly proportional to the strain, and also the shear stress also directly proportional to the shear strain, and the cross section what we are taking should be plane before and after twisting, the application of twisting moment. Okay, and also this angle of twist should be the it rotate through the same. So there is angular twist should be the same, and also this material should not load it beyond its elastic limit. Okay, in that case this elastic theory will not be applicable. So now we will see some important equations to get the torsional equation. The first one, we have to calculate the shear strain. Okay, so what is a strain? That is a change in dimension divided by the original dimension. So the shear strain we are representing by gamma. Here this if you are taking any shaft which is having the radius of r, and when it is subjected to the twisting, the angle of twist is taken as theta. Okay, so this ratio between r theta divided by L will give the shear strain. The shear stress you can derive this from the Hooke's law. So you know that from the Hooke's law, just we can get tau equal to G into gamma. So here already you know that gamma is r theta by L. So therefore from this we can get the shear stress. That is a tau equal to G r theta divided by. And next we have to calculate the torque due to this shear stress. So here to get this, first you have to find the area of the small element which we have taken, that is a 2 pi r into dr, 2 pi r divided by dr, and the shear force is nothing but the force stress is nothing but force by area. So therefore force equal to stress into area. Okay, and the torque is nothing but this shear force into the radius will give the elemental torque. If you are multiplying these two, you will get the this elemental torque. And if you are substituting, you know that tau equal to tau max into r divided by r. So this is a linear distribution. So whenever if you are substituting this, you will get finally tau max by r small r capital R into 2 pi r cube into dr. So this is the elemental torque. So next, if you are so if you are going to this equation, so after substituting everything, you will get the torsional equation of the T by J equal to tau max by R equal to G theta by L. So now in this session, so we have seen some of the equations. So what are that? The first one is a torque. The torque equal to tau max divided by R into J. And next one is the shear stress. Shear stress tau equal to G into gamma. So the gamma is nothing but R theta divided by L. So therefore shear stress just we got at G into R theta divided by L. The angle of twist. So from simplifying this, you can get the angle of twist. If in some places the angle of twist is unknown, if the rigidity modulus and the shear stresses we are knowing, we can in that place we can get the angle of twist like this. And the torsional equation what we derived is T by J equal to tau max by R equal to G theta by L. So these are the things we have seen. So now in this session we have seen that what is the importance of torsion, what are the practical applications of the torsional equation, why the civil engineers should do that, and just we saw some of the important equations in the torsional derivation. So thank you for listening this video. Thank you.